Hi, everyone. A warm welcome to this episode of AIExplore podcast. Today, we are going to explore real-time AI, or the so-called streaming AI, and its relevance with none other than Ralph. Ralph is the ex-CTO of Forecasty.ai and a world's leading expert in streaming and Kafka. And he wrote several articles and books on streaming, especially on the Kafka side. He holds a PhD in NLP. Back then it was not called NLP, but now it is. Now people are recognizing the importance of NLP. And he worked in world leading organizations like Bosch and SAP. And in this episode, let's hear what he has to say. Now, Ralph, a very warm welcome to this session. Maybe let's set the context a bit. So just give me a little bit perspective of why you think real-time data is important in AI applications. Over to you, Ralph.
Yeah, thanks. So the thing is that AI is currently mostly done in a static way. So you have your data sets, you do the machine learning on it. Even if you have generative AI, that happens. And if you include real-time aspects, if you need real-time aspects, then this isn't enough. So you need more data which is fresher, which is more frequently updated. And for that, streaming is kind of the typical way of doing it. So what you would do is to add current data, fresh data to your existing machine learning model, and on the one hand enhance your machine learning model, but on the other hand also work with the fresh data and include it into your machine learning model.
That's absolutely great. I mean, I also think that, a lot of emphasis is given on generative AI without giving due respect to the real-time data streaming. So for some of the audience, I mean, it's very crucial to understand what is a real-time data and what is historical data in the context of AI. So if you can give a little bit of explanation to that, that would be amazing, Ralph.
Yeah, you can basically think of it as, so you can think of static or historical data as data which you have in your database, for example. So for us, I mean, I'm working at Migros now, a retailer, one of the two large retailers in Switzerland, 30 billion plus revenue company. And what we're doing, we have, for example, a database of products. So we see, in this database, we can see what products we have, what prices are the current prices, product descriptions and all that stuff. But of course, the world is changing, and especially in retail, even more in financial institutions, if you are working for a financial company. And in this sense, what you need is, what's happening is that the world is changing, that data is constantly updated, and that usually isn't reflected directly in your database. So your historical data is mostly outdated, and what you need is to make it fresher. So that's the thing, and for that you need real-time, or you need some kind of add-on to your architecture, which gives you more real-time, which gives you more fresh data which is constantly updated. For example, in the case of products. So if you have product data, then you need updates to your products, because probably you have more new products in your stock, or you're changing the prices, you're doing discounts or something. This has to be added to your data set, to your historical data set. And usually that's being done using streaming nowadays. Because with streaming, you have a near real-time technology which allows you to update data as it comes, as it happens. And then you can also bring that to your customers right away.
Yeah, I mean, people know streaming, but YouTube streaming and live streaming, but I think not many people know about the data streaming, which is what we are talking about here. Yeah. One crucial aspect, Ralph, is basically like once you have a large language model like ChatGPT, which is basically like trained on historical data, could you add this real-time data on top of it, or do you need to train the whole model again based on the updated data? I mean, is there a workaround for the organizations, with respect to this specific challenge?
Yeah, definitely. I mean, it's not feasible to really retrain your model all the time, because that takes too much time. That would take another day or weeks. I don't know, depending on the size of your large language model. So in this case, what's being done is to use what's called RAG, that's Retrieval Augmented Generation, which kind of is a hybrid architecture between using an LLM, but having a front end, which essentially also takes a look at more more recent data, right? So, and that's often being done using, for example, vector databases or databases which have vector search capabilities. And with that, you enhance the parsing of your input. And before you send over the prompts to your LLM, you basically ask your database for older data. You also ask databases which are more frequently updated together with streaming. And you kind of augment the data which you send to the LLM before you send it over. What you can also do is you can, in a post-processing step, you can also take the response from the large language model and then enhance this response with fresh data, for example, the prices of the products.
Okay, so this means that, we can think about it in two different steps, meaning you train the model with all the data up to a certain point in time, and then add another layer of like an updation layer, so to speak, which is light in terms of processing.
Yeah, and I mean, after a certain amount of time, you can also use that additional data which you have collected to retrain the entire model to bring that up to date. But usually what you do is you do that dynamically. So this RAG architecture allows you to be much more dynamic in terms of generative AI. You're not completely dependent on the large language model itself. You can add information which is more recent to that model, essentially.
So, that's quite good that you discussed a little bit about the real-time and historical data processing. Now, the major challenges that the organizations are facing is basically like how to set it up in an architecture which is sustainable, so to speak, like how to actually tackle this challenge of real-time data updation. So can you explain a little bit on like how organizations can handle it better in terms of technical architecture as well as, in terms of people and organization?
Yeah, it's essential to have an architecture which is a bit more broad. So you don't just use the large language model, whatever it is. It can be OpenAI or Mistral, whatever. But you build something around it. So the typical architecture is that you have this RAG step before the large language model. So you have the prompt from the user, and then you have an additional parsing step yourself. So you parse it, you try to find the necessary information out of the prompt, which you can which essentially requires you to leverage more updated information.
Yeah.
Could also be information which is particular to your company. So it's not just about real time, it's also about data which maybe only resides in your databases, but is not found in the large language model. So what you do is you take that additional data first, and you either add it to the prompt for the large language model, or you keep it in mind for the response so that you can add it on the response later. So that's typically done. And to update this data in a streaming manner, what you do usually is, I mean, we have these steps. So we have the large language model in the middle, so to say. We have the pre-processing step, which involves this retrieval augmented generation step.
Yeah.
And we have the post-processing. And in the pre-processing step, you usually have databases that can be vector databases, for example. And what you do usually is you have a streaming component, a streaming platform, which in a sense gives you constantly new updates flowing in. These updates are then persisted in your database, for example, in your vector database, Pinecone, Milvus, whatever. And this database is then used in this pre-processing step. When you get the prompt from the user, you augment this prompt and send it off to the large language model. So that's what.
Oh, that's a clever one, meaning that you include this new real-time signals during or just before the prompt, so to speak. And then one challenge there would be like you do not know what are the important topics that you need to actually feed the model during the prompt, because if you that's actually susceptible to human bias, so to speak. Or like I can determine, or you need to have a policy around that, and so on and so forth. Okay, got it. So that's still doable, but it's a little bit challenging to get there, so to speak.
Yep.
Now, one of the topics is really the practical applications of, let's say, the real-time streaming and the real-time AI. So one of the broad industry where it's very, very important is basically financial industry, where, you know, stock markets and where historical data plays a role, but not the major role is played by the current economic scenario and the current demand and supply, so to speak. So how can they leverage this real-time AI, or is it something that they have to wait until a new architecture or a new technology comes and then does it for them? Or is it possible for them to actually use it at this point in time, where every single second plays a major role?
I think that they do it already. So that's, I mean, financial industries is a great example, because that's also where streaming was mainly used in the past 10 years. So that's why what's one of the main use cases for streaming, for data streaming. I mean, it's, again, not Netflix streaming. Also online applications like, I mean, LinkedIn, for example. LinkedIn was the birthplace of Kafka, which is kind of the de facto standard for streaming.
Oh, that's great. I mean, that's something that I didn't know. Can you explain a little bit on the LinkedIn and Kafka streaming, how they are related?
Yeah, so essentially Kafka was essentially developed at LinkedIn and then brought to the open source.
Wow,
directly.
okay.
There's also other companies like Uber. I mean, these big tech companies, Uber, Apple, they are all already working with streaming for 10, 15 years now.
Yeah.
Because they need, what they found out is that it's essential for getting new customers, or for having customers staying on board, not churn, because the customers want to have updated information, especially, I mean, in mobile apps like LinkedIn, for example, or Uber, where you need to have like the most recent updates all the time. You don't want to wait for your taxi because the information in your app is outdated at Uber or Lyft, for example. So that's where streaming comes from, these tech companies. And what they're doing now together with AI is to have AI models which are, again, partly static, like the large language models, but also other AI models. Or also in the financial industries, you have machine learning models which are, again, partly or mostly static, but trained on historical data. But there's constantly flowing updated information coming in, which is used to retrain these models.
Okay.
Right, so that's.
So what would be the frontier in terms of like real-time AI application in financial markets, so to speak? You know, where is the hurdle? You know, to get that accuracy a little bit a notch higher than what it is right now, from your perspective?
Yeah, it's mainly it's a cost factor, I think. So because it's still the case that streaming is kind of hard to and costly to implement. So you still need experts in streaming still. So there's, for example, stream processing frameworks like Flink. That's a very popular one.
Yeah.
Where you do processing on the stream. So you do, for example, you derive real-time insights from the streams, which you use for triggering alerts. For example, I have to buy this stock now, or I have to sell it.
So it's like real-time training as well of the streaming data. So as the data come by, there is no lag between, let's say, the streaming and also the training.
Yeah, so that on the one hand, for machine learning, that's real-time training. You can also have rule sets which are a bit like manually driven. So you have some manually derived rule sets which you directly execute. It's kind of a mixture, and that's being done already for, I think, in most bigger financial organizations right now. It's also being done for many mobile apps, right now, especially the bigger ones. I mean, TikTok, for example, right? So they have a huge streaming architecture behind, based on Kafka
Okay.
and stream processing. All these tech companies, Facebook, for example, they are all using streaming under the covers. You don't notice it, but it's there. And they use it for online retraining of their models. They use it for automatically having alerts or sending out messages to the customers and all that stuff. And that has to be as quick as possible, right? But for normal companies, non-tech companies, there's still kind of a gap. So there's a knowledge gap, a skill gap. So there's because you need these highly paid experts for getting this implemented. That's one of the bigger problems, even though things are changing. So in the last, I would say, 2 years, all these streaming companies have, and also non-streaming companies like Snowflake or MongoDB, they have found out that streaming is essentially the way to go forward, and they're building more and more convenient or easy to use features based on streaming. So it's getting more democratized now in the last 2 years, and it's getting even more democratized over the next 2 years, I think.
So that's a great point that you made right there with the streaming AI and how there is a difference between the organizations which are more tech oriented and the organizations which are not tech oriented. Now coming back to the industry that you're working on, which is retail, how can it impact, let's say, the business value, this streaming AI, so to speak?
Yeah, there's multiple venues. So that, for example, what we have, of course, mobile apps for customers, and what we can do, we can, for example, take the pay slips, so when the customers buy stuff at the checkouts, we get the pay slips on our streaming platform, and we can derive live insights from that data. So we can find out what the customer has bought at the moment, and then we can make suggestions about other things to buy, maybe in other shops of our brand. So that's something we can internally we can use streaming for updating our stock levels immediately to find out what we have in stock and what we haven't, and also we can also bring that to the customers so that the customers don't go to the shop and want to buy something which is not there anymore. So these kinds of things we can already do, but it definitely depends on the organizational level when it comes to streaming, because most non-tech organizations are not adopting streaming in a broad manner. So that's what's different here at Migros, for example. We are trying to build it in a more generic fashion. So we want to have more and more data on the streaming platform to have it real time and then to be able to use it. And that's a barrier. And again, as I said, so there's a big hurdle or barrier still for the adoption of streaming, because it's still pretty hard to do, hard to use. Even though, as I said, things are changing quite rapidly now. So there's more and more libraries and startups coming up now, which, for example, help you to work with streaming directly in Python. So that's the lingua franca for AI. For example, you might know, I mean, that's maybe a bit deep, but you have data frames often. So when you work with data and machine learning and all that stuff, you have data frames, for example, Pandas data frames or Spark. And then, and you can now, there's software to make these real time. So you can work with real-time data frames. There's a bunch of startups now, for example, Quix, which can do that. There's also more and more software which makes it easy to use streaming data in a database fashion. So that's streaming databases. That's the book you were alluding to before. So that's a book coming out in summer. For O'Reilly, that's called Streaming Databases.
And we will provide the link to that book in the description of this video.
Exactly. And so there's more and more stuff coming which makes streaming easier to use. So you can basically ask questions to the streaming data like as it would be a database or a file. So that's what's coming, and that's what's making streaming much more accessible over the next years, and which allows you to bring in streaming into your organization easier, more easily now. And that will definitely help also non-tech organizations to pick this up and to become a bit more like these tech companies.
Yeah, I mean that's wonderful. I think a lot of startups are actually bridging the gap between tech and non-tech companies as we speak, huh? And that's
Yeah,
really encouraging actually, because
yeah.
companies can actually get a lot of value out of data, especially the streaming
Hmm.
data. Yeah, but they are lagging behind a bit. But it's a great. Now let's move on to the next topic, which is basically generative AI models that we see. For
Yep.
example, ChatGPT. Who primarily deal with static data sets. I mean,
Hmm.
and they lack the ability to incorporate new information in real time, and that
Yep.
can lead to some unpleasant experiences when you actually interact with the models. So
Hmm.
one question that I have is basically, can ChatGPT in the future become real time, meaning real time training, models changing every second? I mean, with the advancement in, for example, the new chip and also the new computing
Yeah.
capability, can we see that happening anytime sooner?
Yeah, I think so. So they might also already be working on this. It's that's something which is definitely coming. So there's more and more push towards streaming data. Also, I think in OpenAI,
Yeah,
there's. I mean, you can already use this RAG architecture, which we talked about before, right now to kind of bridge that gap.
yeah,
But I think with the new NVIDIA chips, for example, and all that stuff, the retraining will be faster, and then you can incorporate new data, fresher data in a more easy way. And I think there's already plugins for OpenAI which you can use for incorporating streaming data. There's, as I said, these Python libraries. There's also River, which is another popular library. So you can basically um, start doing this now and be at the forefront, so to say.
yeah. So there, one question, additional question there, since you are more expert in that direction. So this adding one layer of training data, through prompts and
Hmm.
all, is it as effective as retraining the whole model based on the latest data? Um, because
Yeah,
there is a difference, huh?
I think there's a difference, definitely. I mean, of course, I mean, also depending on the context window size, which is
Yeah,
also increasing now, um, you can add a lot of data in your prompt already.
yeah,
But to be able to really incorporate lots of additional data, that's not enough. So it's not enough to add this to your prompt and to the context window. So, um, I mean, I see this context window size increasing more and more
yeah.
over time, and then you can add more directly without having to retrain. But there will always be kind of a trade-off which you have to make because the having the data in your model is always better than having it bolted on top, right?
Yeah, I mean, there one existential question is, like that could be the difference between human intelligence and artificial intelligence in the future, because human intelligence, like we are getting retrained every single minute, whereas
Hmm.
AI models, that's static, it has
Yeah.
lag, so it doesn't incorporate all the latest information, and it cannot make real-time decisions based on real-time insights, so to
Hmm.
speak. So is that the barrier between the human intelligence and artificial intelligence that's going to happen in the future? Just a pure
It's
philosophical
still,
question, so
yeah,
to
yeah.
speak.
It's, I mean, at the moment, it still is one of the barriers, definitely. But I think this can be brought down more and more by technical advances. But what I see more as a problem or as a hurdle for generative AI is that it's very hard to augment it with reasoning, right? So because
Yeah,
actually generative AI or large language models, they can't reason very deeply. So they can reason to a certain extent. They can do,
yeah,
they can find out um, data which is fitting together. They can bring that together, for example, but they can't really do stepwise reasoning, which you would need sometimes. And that's I think also another hurdle, which is not really dependent on real-time data. That's more dependent on the architecture of the models, which
yeah.
hopefully will change.
Which is basically you are talking about like how they reason. Do they reason like a human, or do they reason um,
Yeah.
based on how the rules are set within their intelligence system, so to speak? Huh?
Yeah. Yeah. And yeah. One other thing is that generative systems can be good for making suggestions,
Yeah,
like 10 hypotheses, but you will still have to check them. for the right one, basically. These are
and
the
also whether they are up to date,
problems.
because things change over a period of time.
And
So
then up to date, yeah, that's the next. I mean, it's kind of a combination of the real-time aspect and also the reasoning aspect.
let's move on to the next one, which is basically I would like to ask a few questions about your experience with respect to streaming AI. What are the two learnings that you made with streaming AI based on your experience, both challenges and opportunities, so to speak?
Yeah. So the good thing is that the challenges are getting lower, or the hurdles are getting lower. So that's one thing. A couple of years back, it was much harder to do it.
Yeah.
There's much better tooling now to do this, to incorporate real-time data into AI models. That's one thing. Another thing is that it's, even though it's getting easier, it's still pretty hard. So it also needs, it basically requires a mind shift in your organization. Very early on, when you basically provide the data. So the organization must be fit or become fitter to actually provide real-time data. So that's one of the biggest hurdles, actually. And especially real-time data which is usable. So that's something which is a big problem up front.
Yeah.
That's even before all the technical problems. And then you need data scientists who can actually work with real-time data. So because most data scientists at the moment are used to working with static data, right? Files.
And most of the data scientists also do not know that streaming data exists.
Some don't, yeah. But it's getting less, so things
It's
are
getting less,
changing.
yeah. And thanks to your work, I mean, you have done fantastic work there to actually broaden that information. Very good. Then Ralph, any closing words before I summarize and then close this session?
Yeah, I mean, I would definitely encourage everybody to take a look at use cases which might be useful or more useful, or which would be bringing you more value if you incorporate updated information, especially if you have customer-facing applications. That's kind of key. So if you have customers like B2C business models, and if you serve customers directly, they want to have their most updated, fresh information on their mobile app, basically. And that's something where you should already take a look at streaming at real-time data, because you can definitely enhance your user experience and then definitely sell more, essentially.
Yeah. Thank you very much, Ralph. I mean, I would also be providing contact information of Ralph as well as the link to his book and a few resources where you can actually start looking at streaming data and intro kind of topics.
Yeah, sure.
Yeah, that would be great, Ralph. And then, thank you very much for joining us. It's a pleasure to welcome you to this episode, and stay tuned for more episodes like this. Like, share, and subscribe for more content. And very warm thanks to Ralph as well. Thank you very much, guys. See you in the next episode.
Thanks a lot.
Bye-bye.
Yeah, cool. Bye-bye.